Electrical system. Objectives. After completing this section you will get familiar with power generation, alternator control, storage, distribution, instruments, and the engine control unit, ECU. Power generation. The DA40NG has a 28 volts DC electrical system. An 70 ampere alternator, generator, is responsible for power generation. It is driven by a flat belt and can be found on the bottom left side of the engine. The power output line of the alternator is connected to the engine control unit bus via a 100 ampere fuse. This fuse is installed in the instrument panel. The current sensor measures the current provided to the electrical system and includes the current used for charging the battery. Should a failure of the main battery occur, the alternator is supplied by two 12-volt, 7.2 ampere-hour sealed lead-acid batteries, which make up the ECU backup battery. They are installed behind the first ring frame. They are connected to the alternator voltage regulator via a 10 ampere fuse by the engine master switch. Alternator control. An external alternator control unit measures the alternator output voltage. The current is controlled via a pulse width modulated signal, acting on the alternator's field coils. The alternator field signal is also modulated to ensure that the output voltage is stable, regardless of conditions. A set of detailed diagnostic functions is also a part of the alternator control unit. These functions warn the pilot using an alternator annunciation and caution messages, which are displayed on the annunciator window and alerts window on the right side of the G1000NXI primary flight display. These messages, amongst other items, cover over voltage or under voltage. Storage. Main power is stored in a 24-volt, 13.76 ampere-hour lead-acid battery, installed behind the baggage compartment frame. The battery relay, located inside the relay junction box behind the baggage compartment frame, connects the main battery to the battery bus 1. It is controlled by the electric master key switch, located below the multifunction display. Additionally, the main battery is connected to the hot battery bus. The electrical system has two 12-volt, 7.2 ampere-hour sealed lead-acid ECU backup batteries that are installed behind the first ring frame. Together they make up the ECU backup battery, which serves as an additional power source for the ECU-B. The ECU bus is responsible for charging the backup batteries. In the event that the alternator fails, and the main battery becomes depleted, the backup battery is automatically connected to the ECU-B via a 30 ampere fuse. This is a safety measure that ensures engine operation in the case of alternator failure and main battery depletion. If the airplane has the instrument flight rules model installed, a non-rechargeable dry battery also will be installed. This battery is used as an additional source of power for the attitude gyro and floodlight. It will supply these systems for 1 hour if the emergency switch is set to on. The dry battery condition must be checked every 100 hours, and it must be replaced every 2 years, or after use. Distribution. A variety of buses are used to distribute power in the electrical system. These are the hot battery bus, the battery bus 1, the battery bus 2, the ECU bus, the main bus, the essential bus, and the avionic bus. The main battery is permanently connected to the hot battery bus and cannot be disconnected. This bus powers the emergency locator transmitter and the accessory power plug. Each of these devices has its own fuse for protection. The electric master key switch controls the connection of the battery bus 1 to the main battery via the battery relay. The battery bus is responsible for providing power to the battery bus 2 and starter. The power input line of the external power plug is also connected to the battery bus 1. A 100 ampere fuse connects the battery bus 2 to the battery bus 1. The battery bus 2 powers the ECU bus via a 80 ampere fuse. It is also responsible for powering the main bus via the power relay. The electric master key switch and the essential bus switch control this connection. Setting the electric master key switch to on and the essential bus switch to off connects the battery bus 2 to the main bus. The ECU bus is connected to the battery bus 2 via 80 ampere fuse and provides power for the ECU A and ECU B and their fuels pumps. The ECU bus is also responsible for providing power to charge the ECU backup battery. A 100 ampere fuse also connects the ECU bus to the power output line of the alternator. In order to connect the ECU A and ECU B to the ECU bus, the engine master switch must be set to the on position. The power relay connects the main bus to the battery bus 1. Power is provided from the main bus to consumers, connected directly to the main bus and the avionic bus, via the avionic master relay. To connect the main bus to the avionic bus, the avionic master switch must be set to on. The essential tie relay connects the main bus to the essential bus during normal operation. Should the alternator fail, the pilot must switch on the essential bus switch. This will result in the separation of the main bus from the battery bus and essential bus, and this, in turn, will cut off power to equipment connected to the main bus. The essential tie relay connects the essential bus to the main bus during normal operation. Consumers connected to the essential bus are powered by it. To connect the essential bus to the avionic bus, the avionic master switch must be set to on. Should the alternator fail, the pilot must switch on the essential bus switch. This will result in the separation of essential bus from the main bus, and the connection of the essential bus to the battery bus 2, which will provide essential power for a limited amount of time. Consumers can include the radio, electrical fuel transfer pump, lights, and other devices. Automatic circuit breakers connect them to the appropriate buses. The circuit breakers can be found on the right-hand side of the instrument panel. The circuit breakers are organized by the bus they are related to. Click on a circuit breaker to see its designation. Instruments. The essential bus voltage is shown by the voltmeter and displayed on the Garmin G1000. Usually, this is the alternator voltage, but in case of alternator failure, the main battery voltage is shown. The current provided by the alternator to the electrical system is displayed by the ammeter and shown on the Garmin G1000. This includes the current used for battery charging. The electrical current is measured in amperes. The landing and taxi lights are integrated into the left wing and can be found near the wing tip. The landing and taxi light switches can be found on the top of the instrument panel, among other light switches. The position and strobe lights, also called the anti-collision lights, can be found on both wings, and are located on the wingtips. They are operated separately by switches that can be found on the top of the instrument panel, among other light switches. The floodlight is a two-dimensional light emitter. It can be found above the instrument panel, from where it illuminates the instrument panel, levers, switches, etc. It is controlled by a rotary button that adjusts the light brightness, and can be found on the upper left-hand section of the instrument panel. The instrument lighting is the internal lighting of the instruments on the instrument panel. The brightness is controlled by a rotary button that can be found on the upper left-hand side of the instrument panel. The pitot probe, which is part of the pitot-static system, is heated by the electrical system. The pitot heating switch, which controls pitot heating, can be found on the bottom part of the instrument panel, near the electric master key switch. The pitot heating system keeps the pitot probe temperature stable, thanks to a thermal switch installed on the pitot probe. An inbuilt thermal fuse serves as additional protection. A pitot fail will be displayed if the thermal fuse is activated. In such a case, pitot heating will no longer be able to be activated, and the system must be serviced. A pitot heat off is also displayed if pitot heating is not switched on. ECU. The ECU ensures correct engine operation and is responsible for monitoring, controlling, and regulating all engine parameters. It also controls the engine actuator, responding to information sent from the engine sensors. As part of the ECU, sensors measuring the following parameters are installed. Oil temperature of the engine lubrication system. The oil pressure of the engine lubrication system. Coolant temperature. Gearbox temperature. Camshaft RPM. Crankshaft RPM. The fuel pressure in the common rail. Manifold pressure. Manifold air temperature. Ambient air pressure. Propeller governor and oil pressure. Power lever position. Voltage. Starter switch signal. Fuel pressure. Voter switch signal. And ECU test switch signal. The ECU analyzes signals received from sensors and calculates necessary control signals based on programmed characteristic diagrams to ensure optimum engine operation. The following signal lines transmit the relevant inputs to the engine. The signal for propeller governor pressure valve. The signal for the rail pressure regulation valve. The signal for each of the 4 injection nozzles. Activation of the glow plugs. And the signal for the wastegate valve. The following signals are transmitted as relevant inputs and displayed on the primary flight display. Glow sparks active. Status ECU A. Status ECU B. And low fuel pressure. The engine has 2 ECUs to ensure smooth operation, ECU A and ECU B. A voter switch integrated into the ECU controls the operation of the engine and enables selection between the 2 ECUs. Under normal operation, the voter switch is set to auto, and selection between the 2 ECUs is automatic. The ECU voter is located on the left side of the instrument panel, in the engine section. More detailed information on the voter switch can be found in the power plant operating controls lesson of this CBT. Please refer to that chapter to learn more. Caution messages are displayed on the PFD in the case of any detected ECU faults. The engine must be serviced should an ECU A or B failure caution appear. Summary. With this section, you got familiar with power generation, alternator control, storage, distribution, instruments, and the engine control unit, ECU.